Let's not waste the time. So I'm here to solve one problem from earth pressure, soil mechanics. Determine the total active stress per unit length of its location. I do not have any kind of source, so that while I'm solving this problem I can take the picture because it's a whole lot of problem. So first I will try to explain how steps by steps. First, the question was, first of all, this gamma, whatever I've written here, it was not given. We need to find it out. In a question, it's only given the surcharge load 14 kilonewton per meter square. This is a rigid wall, 3 meter. From this is 3 meter and this one is 7 meter. So first what we did is, this is my step one. First we need to find out the gamma dry, gamma submerged value. So from this formula, gamma D equals to G gamma W1 plus E. From this formula we can find out the value of gamma dry. It's 15.76 kilonewton per meter cube. Similarly, for the gamma submerged is G minus 1 gamma W1 plus E. So from here we get the value of gamma submerged is equals to 9.81 kilonewton per meter cube. After this, we need after finding out the value of gammas, we will proceed for step 2, which we need to find out the horizontal force, active earth pressure. First we will see at A what is the value of sigma V. Sigma V is vertical pressure acting. We can clearly see that it's 14 kilonewton per meter square. So we'll simply write it as 14 kilonewton per meter square of a surcharge. And sigma H is equals to, we know that sigma H is equals to Ka into sigma B. For Ka we are given with a pi equals to 30 degree. So we will simply for value of Ka equal to 1 minus sine pi, 1 plus sine pi, just equate 30 degree here and you will get the value as 1 by 3. So Ka is 1 by 3 and sigma B is 14 kilonewton per. From here we will get 4.67 kilonewton per meter. At B, sigma B, we need to see at B how much vertical load is acting. 14 kilonewton at the very top, and at this point it's going to be gamma dry into 3. Okay, gamma dry is 15.76 kilonewton per meter cube into 3 meter. From here we'll get 61.28 kilonewton per meter square. For sigma H is Ka by sigma V is 1 by 3. Just multiply this with Ka, so we'll get 20.42 kilonewton per meter square. Similarly for case 3, at here sigma B, how much will be the sigma B? You can just see it from the figure and you can determine. It's 14 plus for this portion, and then for this portion is 14 plus 15.76 into 3 plus 7 into gamma dry value. It's how much? 9.81. This. So from here it's 129.95 kilonewton per meter square. And we can see that here submerged, we'll also find out the value of the submerged. Here for that we need to find out the pore water pressure. Pore water pressure is equals to total stress equals to effective stress plus pore water pressure. So we need to find out the pore water pressure here. Pore water pressure is due to forces acting on the water, gamma W into H. Gamma W is the unit weight of water, and H 9.81 into 7 is 68.67 kilonewton per meter square. So sigma V is going to be my Ka sigma effective. It's going to be an effective because now it's unsubmerged. Ka sigma B dash plus U. Always remember that this Ka will only act with the soil, not with the water. That's why it's only multiplied with this soil pressure, this sigma V. But in case of pore water pressure, you won't be multiplying with this Ka. 1 by 3 into 129.95 plus 111.98 kilonewton per meter square. After finding out the value of all the sigma H, we'll draw the earth pressure diagram. So in the very initial it's 4.67. आप देख सकते हैं यहाँ पे 4.67 kilonewton per meter square, and then you only need to see the sigma H value. After that it's 20.42, and after that it's 111.98. So it's linearly varying 4.67, 20.42, 111.98. and now what you need to do is divide all of these in a section, or you can do it in any way you like that would stuck into your mind. But for me, I will do like this. I've seen it from Sir 4.67. This is my figure 1, figure 2, figure 3, figure 4. We have divided into numbers of areas. So first you can see that first one is a rectangle. So we'll find out the PA1 force of this. The force is average stress into area. It's probably, so average is we can see it's 4.67 kilonewton per meter square into area, 3 into 1, 3. Its height. If it's getting an issue for you, then you can just remember it as area of a rectangle is what length into breadth. So our length is 4.67 and height is 3 meter, 14.01 kilonewton per meter. And for case 2, it's a triangle. The area of a triangle is half into base into height, 1 by 2 into 15.75 into how this 15.75 came. So you can see that it's 4.67 and it's 20.42. So in order to find this length, you need to subtract 20.42 from 20.42 to 4.67. So we'll get 15.75. So it's the PA2. Now for the PA3, it's rectangle, area of a rectangle. The base is 20. It will be same 20.42 into, but the height will vary. It's 7 meter. And for some PA4, it's triangle again. Half into base is 101.98 minus 20.42 is 91.56. It's 320.46 kilonewton per meter. And after the finding out of the PAs, you need to find out the Z in order to find the Z bar. So first we'll see for this figure 1. This is my Z1. Z1 is going to be, this is my 7 meter, and for the rectangle it will act at a h by 2. So 7 plus this height is 3 divided by 2 is 8.5 meter. H2 or Z2 is this section. It's but it's triangle, so it will act by h by 3. 7 plus 3 divided by 3 is 8 meter. Similarly for the this figure 3, this is my rectangle again, so it will act h by 2. Our h is 7 and 2 is 3.5. Figure 4, Z4 is going to be, it will act, it's a triangle, h by 3. 7 divided by 3 is equals to 2.34 meter. After this, what you need to do is our final. We need to find out that the total P is equals to P1 plus P2 plus P3 plus P4. It's 501.035 kilonewton per meter. And after finding out the P, you need to find out the value of Z bar. Z bar is equal to Z1 P1 plus Z2 P2 plus Z3 P3 plus Z4 P4 divided by total P. So from here you get the value of Z bar equal to 3.11 meter. That's it. I hope you understood it. Please take a picture if you'd like